all that you've given us, and we ask thee that we are able to do well today and be able to get what we need to get done, and that we will be able to understand the material. And we love thee so very much, and we ask these things in Jesus Christ, amen.
Amen. Thank you, Ashley.
Okay, so I was talking with Jamie, and you know how we had the two left of making inferences and taking action. So she was looking, like, on the paper, the document that I was filling out, you know, we put everyone's name, and then she said in the group study, it has make inferences and taking actions as one. And so I went and looked, and it does look like those two just go together.
Okay.
Maybe it will help you. Would you be okay with that?
Me?
Yeah.
Oh yeah, no, totally. Like I said, it looks like it's just one thing, so I can do it.
Okay, then we'll just put that. So we have, I'm doing design a study. Ashley is determining the data. And then Jamie's make inferences, take action. Then Mildred is the PowerPoint. So each week we can just go through those things. And again, I'll submit mine this week once we decide which studies we want to do.
Okay.
So, anybody want to go first with their idea or anything?
Okay, so we're not going to talk about what project we're going to do, or?
No, that's what we're doing now.
Oh.
So, I was thinking we could, or like one example, what is it? You, like, just survey men to women with it, but you do, like, if they look both ways before crossing, like, an intersection, like college students. But, like, you know how, like, you have to determine, like, do it independent, or, yeah, where it's men and women, or whatever. I don't know. That's how you like to, what's the word? To determine, to separate the groups. Like, if, like, more women look before men before crossing the street, or, like, something like that. I don't know. It's kind of dumb, but.
Okay. Well, that's Ashley's idea.
Okay, so I checked on the ones that I was telling you yesterday, and it's called, okay, so you choose participants, and so it's chosen by a convenience sample. And then we, you know, depending of the people that we interview, we give them the age of the group between, like, let's say 20 and whatever, and 30 or 20 or whatever. And then we describe who we interviewing, like, let's say 10 males and 10 females, whatever the sample could be. And the materials will be just, you know, an iPhone or whatever, because whenever we ask them, okay, think about the red dot or whatever, so then we time them with the iPhone or whatever way you want to time them. Let me see. Okay, so we asked them to think. Okay, let me see, because I copied this. So we tell each participant either to think or not to think about a red dot, and then we time them, and then we just we organize the results. We put the information on this SPSS, and we do the whole, you know, we calculate the standard deviation, the mean, the whatever, everything that we need to do, and that pretty much is, you know. So.
Jamie, did you have an idea?
Well, my only idea, it kind of same as the look both ways, where you compare the boys and the girls together, because I think that would be the simplest way. But mine was just to see which gender would be more likely to cheat on a school assignment or a test or an essay, you know.
Mhm.
Whatever, I go with whatever everybody wants to. I have no.
Okay. Really quick for my idea, it was I looked more into the height of the women, and I just picked women as a specific gender.
Yeah.
So I did background research on it of like the average that they have, and Centers of Disease Control and Prevention says it's 5 foot not 4 inches. And that they also women stop growing around the age 14 and 15, 2 years after your puberty starts. And so then I was thinking we measure between 20 and 60-year-olds because, sometimes as we get older, our height decreases. So I was thinking measuring between 20 and 60-year-olds. So it'd be a one sample t-test. We compare what we get. We get like the mean and the standard deviation with what has been given from the Centers for Disease Control and Prevention website. So that was just my idea. But we can decide.
So on yours, we don't interview anybody. We just do research on whatever data that is available from there.
No, I did the research to see what the average is that other people have done, and then we would go out individually, take heights of 10 other women, and then we take our results, run it through SPSS, and then compare it to what has already been done before.
I like that
I
one.
like that one.
Sounds so easy. Like way
Okay.
easy.
Just like measure my roommates.
Right? Yeah, I picked girls because I was like, I have 2 sisters and a mom. And I was like, there's 3 right there. And I think we could even measure ourselves.
Like some friends at school I can do. Super
Yeah. So we could
Okay,
do
so
that.
let's
Yeah, I have one really short roommate and one really tall one, so that would be kind of fun to have in there.
Yeah. We can do that. All right. So I will just email with everything that I found to you guys after this.
Okay.
Compare to that, and then we can just start combining our research. Our next assignment is due July 4th, and so we'll just want to start running things
Okay.
for that.
So with this group thing, one person is the main writer, and then do we all have to turn in a copy of it, or does one person turn it in?
So one person, we all work on the date, like all the stuff together. So like the things that you're doing, we're just gonna work on together. You just submit it. You're just the transcriber for your 2 inferring and whatever. But we're all working on it.
Okay.
Sense. So,
good.
Well, if we're good there, I guess start on the quiz.
do we have to like make a survey though?
Well, we're just getting heights, right?
Yeah.
Oh, I guess I didn't know. Do we just like start asking people, like, and just doing it like informally?
Well, how many people should we
We
collect information from? 10?
Yeah, individually, I think we should all do 10. That gives us 40.
10 girls.
Yeah. Between the ages of 20 and 60.
Okay.
And we'll get their ages as well, right?
Yeah. Yeah, so do that as well. That would be good.
Perfect.
When do you want this by?
Oh, in the next 2 weeks or so, I'd say, just so that we can start running it. Yeah, but at least by the 28th or 29th
Okay.
this month, so when we meet then.
So, okay, perfect.
Cool.
Awesome.
Yay, that seems
All right. You want to get started on the quiz?
Yes, I do. And I just went
So,
to and I found out that answer for question for last night.
Which one was it?
The one that at the bottom.
Uh-huh.
Yeah.
So you just use where it said like it was like less than 50% if they lose or whatever. You still do the 0.5 minus 0.52. So it's p hat minus p over the square root of p, and then times 1 minus p. It's here. I can't really describe it, but it's literally the z-score formula. We have to use 0.5 because we don't know which number to use. you're like, oh, 0.48 or 0.49, it was, you'll literally get the answer right when you plug it in, like, to the thing. I don't know, like the z equals formula.
Oh,
So we did everything right, it's with 0.5.
gotcha. That's good to know.
So,
Thank you, Ashley.
you're welcome.
Thank you.
Mm-hmm.
Okay.
Okay. Um,
I'm looking with the homework this time. It seemed a bit easier for me to understand.
yeah.
Question 3. The symbol for the true population proportion is which of the following?
B.
Yep, B.
It's P hat?
Yep.
Okay.
I love how that's an official term.
You know, it's weird.
Okay.
Alright. For the next two questions, suppose n equals 100, p equals 0.25, and p hat is 0.1. The requirements for constructing a confidence interval are satisfied.
Yes.
Yes.
Isn't it, you have to do the n times p is greater than or equal to 10?
Mm-hmm.
Yes.
And then, okay, and that, so they have to be greater or equal to, and then the n times 1 minus. Okay. I get that.
Let me ask you something, but in that, isn't it? Oh, yeah, never mind. But then which one is X on this case?
You don't need to find x for this one. You're just solving for n times p hat and n times 1 minus p hat.
Oh, okay.
And then you just solve for that.
Mm-hmm.
Yeah,
Yeah, we see if it's
yeah.
greater or, okay.
And then requirements for the hypothesis test are now just n times p and not. And then we have a
P.
25 with 25.
It's 25, so would it be true?
Yeah, I got true for that as well, just running those equations.
Yeah, but the requirements for conducting the hypothesis test are satisfied. I mean, 100 by 20 times 0.25 is 25. So how do we know if it's satisfied or not? What is it?
It's greater than 10.
Oh, okay. So 1 second. So that means that they divided the question, the requirements. Okay. Yeah, never mind. Okay.
Okay.
Do you want me to read 6?
Yeah.
A study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for first-degree murder was taken. Of these, 45 of the defendants were found guilty. Find the p hat, the point estimate of the portion of the first-degree murder defendants who are found guilty in this state. I got 0.75.
That's what I got as well.
Hold on. Yeah, I did too.
Mildred, do you understand how I got 0.75?
Okay, I'll have to work on the formula.
This one is, it's just x over n. So you take what they got. So they got the 45 back, and it's divided by the 60 of the sample size. So when they ask for the point estimators, it's just
It's
what
just
they actually
2
got
x
back
over
out of it.
n.
Yeah. So that's what we got, 0.75.
Okay, got it. Thank you.
Okay. Create a 95% confidence interval for the true proportion of first-degree murder trials in the states where the verdict is guilty. Input your answers for the margin of error, lower bound and upper bound. Oh man. Determine margin of error for the 95.
So did you guys do the Excel thing? I think you
Yeah.
did Excel,
Okay.
that document that we got.
Right, opening that up now.
Where is that? I couldn't find that, the Excel. Where was it?
It was on the note, or like in the chapter 17
But in the book?
in the book, yeah.
Yeah.
I
In the
couldn't find
reading,
that.
it says click on this link and it takes you to the page. And it's like the page where we went to when we downloaded SPSS, and below that is the Excel sheet.
Okay, thank you. I'm gonna look. I couldn't find it. I was like, where is that?
Because then you just plug in the X and the N and the
Yeah.
information you want. Okay, so if we do it backwards, what did you guys get for the lower bound?
Hold on, I'm just opening it.
Okay.
So you put in X is 45. And then 60.
I got 37.63.
For the margin of error? Or
For the margin of error, I got. Oh, wait, hold on.
For number 7, I got 7.37.
The margin.
I'm not sure about that one. For my lower bound, I
But
got.
these were the 3 that.
Wait, the margin of error, do we have. My tutor told me he gave me the margin of error formula, and then if we know P, do we know P? No. We know P HUD.
No,
P is 0.75.
Oh yeah, so when you do that, it's Z, so it's the formula is 1.96 times, and then it's the square root of P, parentheses 1 minus P over N, and that's the whole square root. And so P would be 0.75. And then N is 60. So,
0.3675.
hold on. Aria, 0.10956.
What did you give for that one?
I got 0.1096.
Yeah, yes, that's what I got.
1.110. Right?
Wait, say that second half again.
So did you get, since you have to round, would it be 0.110?
It would be round to 3 decimals. It would just be, would it? Or is it just 109 because you can't go higher?
I don't know.
Oh, actually, I think you're right. 0.110. I think that's right because I did it by taking the higher bound minus the lower bound divided by 2, like you said, and I got 0.11 with that.
Yeah. And that
What
was
did you get for the higher and lower bounds?
Lower I got 0.640, and upper I got 0.860. It's in the Excel sheet. It's already on 95%. Confidence interval, everything is already set. And then X, what was our X again?
0.640?
X is 45. X 45. N is C. And then, you look in the one proportion Z test down on the bottom. It says confidence interval lower is 0.640, upper is 0.860.
Now,
So
let me
that's
ask you something. Can this be plugged into that Excel sheet to get the
you plug the X and the N. So what we got back and the sample size in it, it does not give you the margin of error. It gives you the lower and upper bound. So we had to do margin of error by hand. And it gives you some other things on there like a p-value, z-score, but we're not worrying about those things right now. So that's it. So did everyone get 8 and 9 and 7?
Yeah.
No, I didn't. I'm sorry, I didn't.
Okay. So 7 is 0.110. 8 is 0.640. And then 9 is 0.860.
0.8. I'm sorry.
Yes.
0.8. What?
860.
Okay, so you did that by doing the formula, right? The p hat plus minus z star square root of p hat times 1 minus p hat over n.
You
right?
could do that by hand, but again, it's in the Excel sheet. It automatically does it for you.
Okay.
So we just used Excel.
Okay.
For number 10, it's increase, right?
Yeah. That's what I thought.
I thought it was decrease.
Why would it decrease it?
Because it starts to get closer. Because if you're looking at the applet, you have better, and then they come closer together. So it would lower. Decrease.
As confidence increases, intervals increases. As sample size increases, intervals decrease. So if you increase the sample size,
isn't it inversely related?
If the sample size increases, the intervals decrease. Is A. Because if you increase the sample size, the confidence interval will decrease. Is A.
Okay, so question 11. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P is 1/2. What is the smallest N can be?
20.
What was that?
Would it be
20?
Just probably my calculator real quick. Yep, I got 20 as well.
And then it's the same thing for 12 except 1/10. And I got 100.
That makes sense because it's 100 times 0.1.
Yep, I got that as well. So 20 and 100.
Okay, so 11 will be what? 1 divided by 2? 0.5?
Yeah.
11 is 20.
Yeah, so you do the 1 divided by 2 and get 0.5, and then you have to, again, it's the requirements we had of NP is greater than or equal to 10. So you divide by 10 divided by your 0.5 that you now have, because the 0.5 is your P and you're solving for N. So then we did 10 divided by 0.5, which got us 20. So then for 12, you do 1 divided by 10, it gets you 0.1, so it's 10 divided by 0.1, which is 100.
I don't know, I got confused. These two.
13.
I got true.
Question. Yes, that's true as well.
So why is it true?
Because you take the 0.6 and you put it into the requirements, and it's over 10. The 0.6 and the 80 are what you would use.
Mm-hmm.
So you do 0.6 times 80?
Yeah.
Yeah.
Again, this is the n times p, and n times 1 minus p,
Oh.
and you just plug
It
those.
has to be over 10. And okay, that makes sense.
Yeah, equal over 10. So that's why 13 is true.
Test statistic.
So what's
You can use the thing for it.
The p-value I got 0.475.
So
Or the p-hat, whatever it is.
38 divided by 80, you get 0.475.
Wait, 40. What do you do? I got 2.105.
For 14?
Yeah. Because it's XO. Just kidding. What am I doing? I just divided it wrong. 0.475.
Yeah, so it's 38 divided by 80. 0.475. Okay, for test statistic, we use the Excel sheet again. So,
I got a negative number.
1 sec. No, it's 0.6.
yeah. Okay. So, Mildred, since you don't have it, I'm going to walk you through it. You would put.
I can find the sheet, the whatchamacallit?
The Excel sheet. Yeah,
Yeah, where is it?
it's just in the reading.
Using the Excel to perform those calculations when you open the book on 4.2 there.
It was just in chapter 17, and while you're reading through it, just go to this link. You click on it, and then the last link on that page you click on. And it takes you to that. So, really quick, Jamie, what did you get for the test statistic?
I got negative 2.282.
That's what I got.
That's what I got as well. Awesome. So we plugged in the X, the N, and then changed the null hypothesis to 0.6. So negative 2.282. Okay, then the p-value still in there.
0.011.
Yep.
Then we reject the null hypothesis, right?
Yeah.
I thought you failed to reject.
No.
Because it's greater than.
No, the alpha is 0.05.
Oh, it's 0.11. That's why.
Yeah.
I was thinking it was 0.11.
That
makes sense. Sorry.
Reject.
So there's sufficient evidence that.
I got C.
That has decreased. So there's sufficient evidence that it has decreased. Yeah. No, it's not. It has to be sufficient. So it's D.
Yeah. Okay.
We missed one of them, it looks like.
Which one?
Let me see. We missed number 3.
3.
Yeah, the symbol for the true population. I guess it's just a solid P, huh?
Okay, yeah, so P, true population. Oh, that one's tricky. So then is P hat?
So true population is just P, and then.
Yeah, because we don't know what the P squiggle is. So P hat must be like.
We haven't studied that P wiggly.
Oh.
Okay, I'm gonna submit it with the solid P. We don't know the other one. Yep, no, 100%.
All right. All right. Well, I'm gonna go because I have to get to my lab. But see you guys. Normal time next week.
Yeah.
Yeah.
All right. Cool.
See you
Bye.
then. Bye, Jamie. Everyone. Bye.
Oh,
This was
long day.
Okay.
all right.
Okay, guys. Thank you.
You're
Thank
welcome.
you. I'll go ahead and submit this, and I'll email just with what I've got.
Perfect.
Okay,
Thanks.
thanks, guys.
Yeah.
Bye.